Hello students. So let's start our part 4 of motion. Our next topic is acceleration. So what is acceleration? The rate of change of velocity. Means if it is changing, if velocity is changing with the time interval, increasing time interval, that is called your acceleration. The body is said to have acceleration when the velocity of a moving object changes either in magnitude or in direction or in both. Either in magnitude or in direction, or it is changing in both. This is called your acceleration. Acceleration, how we show like this? We show v minus u by t. And don't be confused if it will show like v by t, this is also your acceleration. This is your difference of acceleration, means from final to initial. So v is final velocity and u we denote like initial velocity. Average acceleration, it is defined as a ratio of the change in velocity to the time interval. Suppose ratio of change in velocity like your this one, change in velocity by time interval, average acceleration, like this we show. This delta v is showing you, delta v means vf minus vi, means final minus initial velocity, difference of final minus initial velocity, and delta t is showing tf, t final, time final by t initial. This is your average acceleration. So average acceleration refers to the average acceleration and its unit is meter per second square. How we get meter per second square? Question mark. See, let's see. Meter per second, like we unit of velocity is meter per second. So we denote acceleration is equal to v by t. So how we will take out this? It was already v. What is the unit of v meter per second, and into again t, and what is the unit of time? Second. So here we will get meter per second square. Okay, this is unit of acceleration. Uniform acceleration. What is uniform acceleration? If a body travels in a straight line and its velocity increases in equal amount in equal time interval of time, its motion is known as uniform accelerated motion. Means, what does it means? You see, if a body is traveling in a straight line and with the time, as the time is increasing in equal time interval of time, like after 4 seconds, then again next 4 seconds, then again next 4 seconds. Okay, first body was covering, body's velocity was 2 meter per second, then again in 4 seconds, then again in next 4 seconds it will be 2, from 2 to it will be 4, and then again 8. So it's a sequence of multiply by 2. So it's going in a particular interval of time, means it is increasing in a particular manner. So it is your uniform accelerated motion, and it is accelerating. You see, accelerating means it is increasing. When it will be 2, the question comes sometimes when if suppose here in all the 3 times, 4 second, 4 second, in all the 3 times, if it would be 4 second, 4 second, 4 second, if it would be 2 meter per second, 2 meter per second, 2 meter per second. So here what you can see, it is going constantly same. So here the acceleration will be constant. So this is your conditions. Don't be confused. Acceleration will be 0. Velocity is constant, so acceleration will be 0. Example like motion of a freely falling body is an example of uniformly accelerated motion of a body due to gravitational pull of the earth. It's increasing in a proper manner or decreasing in a proper manner. So it is an example of freely falling body. What is non-uniform acceleration? When velocity increases by unequal amounts in equal interval of time, then its motion is known as non-uniform accelerated motion. Means sometimes velocity will be 2 meter, in 4 second, 4 second, in 4 second. So velocity will be 2 meter, then again 8 meter, then suppose 12 meter. So it is in irregular manner, it is increasing. So uh, here the motion is non-uniform accelerated motion. Then its motion is known as non-uniform accelerated motion. An example is car moving in a crowded street. Sometimes car, you give brake to car, it's going very fast, so sometimes it's going very slow. So this is example of non-uniform accelerated motion. Types of acceleration. Two kind of acceleration is there. Positive acceleration means if the velocity of the object increases in the same direction, the object has a positive acceleration. Same direction means if it is going this side, same direction means it is not changing, sometime here, sometime here, it is not changing its direction. So it call you positive, and in acceleration, value of acceleration always comes in positive, means with the positive sign. But if the velocity of a body decreases in the same direction, the body has negative acceleration, or it is said to be retarding. Means example, a car slows down. So retarding position, what is your, if it is sometimes its body is decreasing in the same direction, एक तो decrease कर रहा है, ऊपर से the body has negative decrease कर रहा है, or in direction, or whether in magnitude, okay, in both cases. So this is called your negative acceleration, minus a. A car slows down. Slow मतलब कम होता है, negatively it is speed is going slow, that is your negative acceleration. So in the crowded means when you are driving a car in the crowded area, so when it is accelerating, when the speed is increasing, means velocity is increasing in a particular direction, that is called acceleration. But if it is you are slowing down your car, that term is called retardation. dv by dt, this is the acceleration rate of change of velocity, and it's a vector valued function, has magnitude and direction. Here you just see, take care, then this is dv by dt, means it is showing both magnitude and direction. So magnitude and direction, so it is showing acceleration. Suppose in place of this, if it would be a modulus, then you will say this is speed, because here it will give only magnitude. Modulus means these two both lines. A body with constant velocity has zero acceleration, means if body is moving with a constant velocity, it is not changing with the time, so acceleration is called zero acceleration. Graph, when you will come to see the graph, you will get the graph like this, vt graph. Here at this part, velocity is constant, so acceleration will be 0. Here it is increasing, so acceleration has some value, and this slope gives you value of acceleration in vt graph. When a body is moving with constant velocity, change in velocity of that body for any given interval of time is 0. The acceleration is said to be 0. Important points. While solving numerical, you have to take care when a body starts, if it is saying in the question, when a body starts from rest, means rest se start kari, its initial velocity is taken as 0. So you will take u is equal to 0. If it is not mentioned and it is given only the body starts from rest, you should know that u is equal to 0. When a body stops or comes to rest, body was moving and at last it stops, so it means it is at rest, and final velocity will be 0. Third, when a body travels with a uniform velocity, its acceleration is taken as 0. Uniform velocity means increasing the same manner acceleration, there is no increasing, so acceleration will be 0. Derivation of equation of motion. First law of motion, v is equal to u plus at. So Let us begin with the first equation, v is equal to u plus at. How we will derive this? This equation only talks about the acceleration. There are two methods of derivation. First, alternate method, and second one is a graphical, alternative graphical method. So here I am showing you simple way of, means alternative method. This equation only talks about the acceleration, time, the initial and the final velocity. Let us assume a body that has a mass m and initial velocity u. Let after time t its final velocity becomes v. Due to uniform acceleration a, now we know that acceleration, we know that about acceleration is equal to average acceleration is equal to final velocity minus initial velocity, time taken. This you know. So what you have to do? A is equal to v by minus u by t, or you can write at is equal to v minus u. Therefore we have equation v is equal to u plus at. Okay, same thing. Thank you.